All right, we're going to look at the fundamental theorem of algebra. So basically what we're going to do is we're going to continue factoring, but now we're going to take it a step further and we're going to solve. So the fundamental theorem of algebra states that a polynomial p of x of degree n greater or equal to 0 has exactly n linear factors, counting factors used more than once. So I'm going to set them equal to 0, and when I solve, I'm going to have at least one 0 in the complex number system. All real numbers are complex numbers with an imaginary part of 0. So basically what we're going to look at is I'm going to look at the degree and determine how many zeros I should have, and then when I find all my zeros, show that that's how many I actually have. So for example 1, we have a third degree, so we're going to have 3 zeros. For this one, I'm going to factor by grouping. There's not a GCF I can take out first, so I'm going to go straight to grouping. So I'm going to group here. So 3x cubed plus 2x squared, that's my first group. So I'm going to take out my greatest common factor, which is an x squared. What's left in is 3x plus 2. I'm going to do the same thing to my next one. I'm going to have a GCF of 2, and I'm going to be left with 3x plus 2. And then I'm going to rewrite those factors and then make sure I set them equal to 0. So I have the x squared plus 2, parentheses, and then the 3x plus 2 equals 0. So once I have my factors, I'm going to then set both pieces equal to 0. So I have x squared plus 2 equals 0, and then 3x plus 2 equals 0. Now I'm going to solve for x. So for this first one, subtract 2 on both sides. So we get x squared is equal to negative 2. I'm going to take the square root. So x is equal to plus or minus, because when you take the square root, you have the positive and negative. Square root of 2 is not a perfect square, but I have the negative, and remember with the negative inside, we can take it out and put I, and then I get square root 2. Right here, these are two answers, 2 zeros right here because of the plus and minus. I have a plus one and then a minus one. So now let's solve for the other part. So I'm going to subtract 2. So you get 3x equals negative 2. Divide by 3. So x equals negative 2 over 3. And then there's my other 0. There's 1 0 here. And if you go back, I had a third degree, so I should have 3 zeros. And I do. I have 2 complex ones and then a real solution, but that's also part of our complex because we would have an imaginary part of 0. So all of these are in the complex number system. All right, let's go ahead and look at example 2. I have, again, to the third power, so we should have 3 zeros. Now I have x cubed plus 9x. I'm going to go ahead and set that equal to 0. Now, I don't have multiple terms. This isn't a sum or difference of cubes. All that they have in common is an x. So I can go ahead and factor out an x and get x squared plus 9. I've factored as far as I can go, so I'm going to set both pieces equal to 0. So x equals 0, and then x squared plus 9 equals 0. Well, x equals 0 is already solved, so there's 1 0 here. And now I'm going to solve for x squared plus 9. Subtract 9. You get x squared is equal to negative 9. Take the square root. Notice you do have a perfect square, which is 9, but it's negative 9, so that's going to give us plus or minus 3i. And then that's our other two solutions. Again, a positive one and a negative one. So there's two solutions there. Plus my solution at 0 means I have 3 zeros. All right, now example 3. Notice you have to the fourth power, so we should have 4 zeros. Again, this looks like a difference of squares. Again, perfect squares. So I could have x squared plus 4 and then x squared minus 4 equals 0. because this x to the fourth, I'm going to draw a little arrow over here, that can give me x squared times x squared. And then this 16, draw an arrow over here, that's 4 times 4. So that's how I get x squared plus 4, and then x squared minus 4. Have to have a plus and a minus in order to cancel out that middle term, and that's why we don't have that middle term. Now we can actually keep going with this x squared minus 4. That is still a difference of squares. So I have this x squared plus 4 in the front, but then I'm going to have x plus 2 and x minus 2 because square root of 4 is 2, and then x times x gives you that x squared. Once I'm done completely factoring, now I'm going to set each piece equal to 0. So I have x squared plus 4 equals 0, x plus 2 equals 0, and then x minus 2 equals 0. These last two are a little bit easier, right? X is equal to negative 2, that's one solution. X is equal to a positive 2, that's another solution. Now let's do this x squared plus 4. So I'm going to first subtract 4. We get x squared is equal to negative 4. Take the square root. We took the square root of a negative, so we're going to have plus minus. This is a perfect square, so 2, and then don't forget that I because of that negative under the radical. And then there's our other two solutions. All right, let's do example 4, and then you can try example 5 on your own. We have a cube, so we're going to have 3 zeros. And then notice this is a difference of cubes. So kind of like what we learned yesterday with difference of cubes, I'm going to take the cube root of both pieces. So the cube root of x to the third, I'll write that out here, cube root of x to the third, that's going to give me x. So a is x. And then the cube root of 64, that gives me 4, and that's your b. So our a and our b, and then we're going to use the difference of cubes formula. So x minus 4, parentheses, and then we have a squared, so that's going to give you x squared, plus a times b, so x times 4, that's 4x, plus your b squared, so that's going to give you 16. Now, I can't continue factoring that x squared plus 4x plus 16, but I'm going to set both pieces equal to 0. This first one should be pretty simple. All we have to do is add 4. So our first solution is x equals 4. Well, for my other part, if I can't keep factoring that, another way to solve for your zeros or your x-intercepts was using the quadratic formula. I'm going to put it on example 5, our quadratic formula, if you don't remember it. So that is our quadratic formula right there. So I'm going to use that with my values that I have here. So A, B, and C. So opposite of B, I have negative 4 plus or minus the square root of 4 squared minus 4 times A times C, all divided by 2 times your A. If I clean that up a little bit, I should have negative 4 plus or minus the square root of negative 48 divided by 2. Well, I think I can simplify the negative 48. I'm going to come over here off to the side, and I'm going to do my little factor, upside down cake or factor tree. So if I keep doing this, 48 divided by 2 gives you 24. 24 divided by 2 gives you 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. I have 2 pairs of 2's. So that's going to be negative 4 plus or minus 4, and because it was negative, the I, square root, and my leftover 3, all divided by 2. I can simplify the 4 and the 2 in the numerator and the denominator. So my final answer should be x equals negative 2 plus or minus 2i, and I still have that square root 3. And then those are your other two solutions because the plus and the minus. All right, example 5 is very similar, except instead of difference of cubes, we have a sum of cubes. So this one is a sum of cubes. Go ahead and try that one and make sure you look over the notes again if you need.